Fine. This is most efficient. However, right now you don't know what is time efficiency. In the first year, you don't understand that. But this is the most efficient sort of sorting among the three you have studied. Okay. Insertion sort. Let's see how it works. Again, there will be same two things. First is like number of passes. Number of passes again would be same logic, equal to number of size of array minus 1. So if your array has 5 elements, so number of passes again will be 4, like in the previous two, selection and bubble sort. Same way for this example also, number of passes for this example will be 4. That will be having 4 passes. Simple. Okay, then what we will be doing in every pass? That is the second thing we need to understand. So let's start. That initially this is our array. Fine. And in the first pass, we'll select this element at index 1. Pay attention. In the first pass, we'll focus on element at index 1. Fine. And suppose we save that value somewhere. The value at the element at index 1, we save it with us. Fine. And then what we simply do is, we will go in descending order. We'll check all the elements before this. Fine. It is simply actually the card game actually. When we play cards, I have these 4 cards. Let's say this one is 10. This is K. This is 10. This is K. This is 2 and this is 3. Fine. This is 10. This is K. This is 2. This is 3. And I want to just sort them. Fine. So simply I'll say, okay, pick 10, and simply if I start from here, it is 3, it is 2. So I'll just simply pick 2 and say, okay, 2 is smaller than 3, so I place it here. I'll swap their position. Fine. Now it is 2, it is 3. It is K and it is 10. I'll pick this value. Okay, this is already sorted, no issue. I'll go to next element. This is 10. So I'll say, okay, this is 10. This is smaller than this, so put it here. This is not smaller than this, so I'll place it here at 3rd place. I'll swap this position. So simply it will be 2, 3, 10, and K. All sorted. So basically on that logic, what our brain thinks in the game sorting is the logic of insertion sort. Right? So simply, again for this thing, number of passes will be equal to size of array minus 1. Or you can say number of elements in array minus 1. So for this example, it would be 4. In the first pass, we'll select the element at index 1. Fine. In this case, we'll go this way. From the selected element to the element at 0th index. Once we reach the element at 0th index, we'll stop. Fine. So what we'll do is, we'll compare with this saved value, this value at index value just smaller than this one. Like in this case, value at index 0 will compare with 40. If it is greater than this, like in this case, 10 is smaller than 40, fine. So we'll do nothing. We'll pass on next. And we'll say we already have reached the index 0, so we will stop. So in pass 1, the output would be very much same. After pass 1, the output would be very much same. Just keep patience. You will be understanding this more in pass 2nd. So after pass 1st, the elements, nothing has changed. Right? Then in pass 2nd, we will select element at index 2. Fine? And save it with us. Suppose we are saving it in variable temp. Right? We save this element. Now we will compare element at index 1 with this element. Fine. And we say, oh, this is greater than 2. Fine. 40 is greater than 2. So that is, we don't want, want all the elements to the left of the selected element to be shorter to it. If they are smaller than this, then fine. But if they are not smaller, they are greater, then we have to do something. If it is greater than the selected element, we'll copy this element to its next index value. So we'll copy 40 here, overwrite 2. Fine. Then we'll move to next smaller index value, that is index value 0. Fine. Again, we'll check either this 10 is greater than 2. We say, oh yes, again it is greater than 2. So again, we repeat the same thing. Copy that value to the next index value. So we place 10 here. Fine. And then we see, okay, we have already reached the index 0. We cannot go further down. So we'll stop here and copy our saved element. Copy our saved element to index 0. So we'll write 2 here. So we'll write 2 here. Fine. So after pass 2, we'll have 2 here, 10 here, and 40 here. Fine. Fine. Now logically look at the significance. Logically, after pass 1, here, when the elements here was 10 and here was 40, we'll say first 2 elements are so in their sorted order. They are sorted order, we can see that. After pass 2, we'll say first 3 elements are in their sorted order. We can say that, yes, 2, 10, and 40 are in their sorted order. Fine. What we'll do in pass 3? In pass 3, we will select, we'll follow the same procedure. In pass 3, we will select element at index 3. And again, we saved it with us. Let's say we saved it in some other variable because it is of major significance to us. So we saved it somewhere. Fine. Fine. Now we saved it here. We said again, okay, check this. 40 is greater than 3. Oh, yes, it is greater. Whenever it is greater, we just copy it to the next index value. So we copied 40 to next index value of the 40. Fine. And then check the element at next smaller index value, that is this one, 10. Again check 10 to 3, not to this index value. 10 to the initial value at here, the saved value, 3. So compare 10 to 3. Oh my god, again 10 is greater than 3. So we again will copy 10 to next index value. So it is 10 we wrote here. Fine. Fine. Now we move again to next smaller index value, this case. Fine. Now we check 2 is greater than 3. No, it's not the case now. Fine. It's not the case. Whenever we find the element greater than that, then in that case we just copy that element to the next index value. And as we reach a place when that element is not greater than 3, we will stop. Fine. We will stop at that place. Is that simple? We'll stop at that place. And once we stop at that place, what we will do is we will put this saved value to wherever we stopped, to next index value to that. Like if j was the indexing, so ij plus 1, we will put 3. That means here, whichever next element, previous element we move to that place, we copy 3, the saved element. Fine? Fine. So we will say after pass 3, like this will be the output of pass 3. After pass 3, we will have these first 4 elements sorted at that place. These are sorted among themselves. Is this simple? See, simply what we are doing is, in every pass, whatever the pass number is, if it is pass number 1, then we are selecting element at index 1 and checking it up to 0. Or check karne mein what we are actually checking is, we are checking whatever element we are selecting in any pass. Now just look, we'll be following just 2 things. Whatever pass number is, we'll be selecting element at that index value that you can see. In pass 1, we are selecting this one. In pass 2, we are selecting this element. In pass 3, we are selecting this element and saving it with us. Because we are doing all other comparisons of all other elements with that saved value. Simple. Next, what we will do is, like in whichever pass we are going, generally we are following is, say, if in pass 2nd, we are selecting element at index 2, this one. Fine. We save that element. Fine. And at index 1, we compare that element to be greater than this or smaller than this. If that element would have been smaller than this, we do nothing. If that element is smaller than this, the saved element, we do nothing, and there we will stop. That's it. Fine. Because the previous one we are already in sorted order, and if we are checking this element, this is already greater than this previous index value, the saved element. So that means earlier one are also smaller than this selected element, so we'll do nothing. We'll stop there. Fine. But second case, if this value at just the previous index value than the selected element is greater than this, greater than the selected element. If it is greater than the selected element, we'll say, okay, move this element to its next index place. Move this element to its next index place. Fine. Fine. And we'll check for element at another previous index value. Again, compare that element with the saved element. If it is smaller, now take two cases. If it is greater than the selected one, then again we would have repeated the thing, moved it to next place. We keep on comparing unless until the selected one is greater than the saved element, we'll keep them moving to their next index value. Fine. In that case, we'll end up only at two positions. Either we'll reach at index 0. That element at index 0 was also greater than this element. So we move this element to index 1 and we'll stop there because we cannot go at index value -1. There is no logic of going to index value -1. Fine. 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 But if second case of stopping, if suppose for this second case, even you take it, this case we take it, if the value is, take this value, take the value of pass 3. The 3, we compared 40 to 3, so we moved it to next index. We compared 10 to 3, so we moved it to next index. Fine. Now we're checking for 2. The next element, next index value we are comparing. Now it is smaller than this. When it was greater than this, we are just moving it to next index value. But once in a case, when it is smaller than the saved element, your saved element is greater than the selected element. When it is smaller than the saved element, then in that case, what you will do? That is your second stopping condition. You will just stop there. And what you will do is, you will see, okay, at this index value, this element was smaller than the saved one. So at index value just previous to this one, just the point where it is stopping, that means all the elements previous to that would be smaller to this one because array is sorted in this side. Fine. So just to next index value, to the stopping point, you will copy the saved element. We'll bring the element and copy it to the next index value. You pay attention here. That is what we have done here. In pass 3, we selected, I'm just repeating this logic for this one. This is very important. See, in pass 3, just follow the logic. In pass 3, we selected the element this at index value 3. Fine. And we saved it with us. Let's say we saved it in a variable tab. Fine, because we want to have it. We want to do all the comparisons with it. Right? Now, we'll compare just the previous index value with 3. 40, the selected one. 40 is greater than 3. So we just put it to next index value. So we just copy it to next index value. So 40 is here now. Right? And we move to next comparison of next element. That is, now we'll compare element 10. Again, 10 is greater than 3. So again, we copy it to next index value. So then we place it here. 40 is no more. Simple. Simple. Then we again go to next index value. That is 2 this time. We compare 2 with 3. Now 2 is smaller than 3. 3 is greater than 2. Or we can say 2 is smaller than 3. Fine. Once this is true, then we will stop comparing elements next to this index value. We'll stop there. Fine. And what we will do, at what index value we stopped, next to that index value, we copy that element. So we stopped at index 0 in this case. And at index 1, we will just copy our saved element. So here, instead of 10, we placed 3. That is the stopping condition. There would be only two stopping conditions. Either you go out of the range of 0, 0 se bhi niche chala gaya. You have even compared the last very first element of array. Fine. In that case, you will copy that element to 0th index. Fine. Otherwise, if in between, like in this case, here you stop because this element is smaller than the selected one. So you will stop comparing further and you will copy the selected element to next index value to this stopped position. So you place 3 here and you stop it. Am I clear with this pass? Because this pass tells you the most complex situation. Fine? Is this simple? Okay, now let's go to next pass. So after pass 3, this will be the values. Fine. Then in pass 4, we selected the element at last place. So in this, the saved element is at index 4 is 40. Then, and we'll start with index value just less than this one. So we compare 10 with 40. 10 is less than 40. Fine. That means already it is greater than this element, or isse previous indexes pe bhi the elements are smaller than this element. So they are also already sorted. Am I okay with this? They're also already sorted with this. So you will just stop at this count. You will just do this one comparison and you will stop. Fine. So as 10 is smaller than 40, that means all previous elements are also smaller than 10. So they will be smaller than 40. No swapping of positions is required. So we stop here. So that will be, you will, with just one comparison, you will stop in pass 4 with this value. Fine. And after pass 4, you'll say all these 5 elements are in sorted order. And that is the case. Clear? Clear here? Just look at one logical perception of this. After pass 1, you will say the first 2 elements are in their sorted order, not at final sorted positions. They are in their sorted order. Right? After pass 2nd, you will say first 3 elements. You will say after pass 2nd, first 3 elements, that is 2, 10, and 40, are in their sorted order. After pass 3, you will say first 4 elements are in sorted order. After pass 4, you will say all 5 elements are in their sorted order. Right? That is the logic is being followed. Am I clear with this? Am I clear with this? Okay. Now let's see. Can you think of coding this one? Can you think of coding this one? Those who want to try, first try your logic and then look at the code. Those who want to try, please look at the first, try your logic and then look at the code. Then look at the code. Now, see the code.
Ma'am, please see my code.
Okay. Who is this dear?
Ma'am, Ritik.
Okay, let me see the screen. Are you showing your code on the screen? Ritik. But either you share your screen or turn on your camera and show it on the camera, then only I'll be able
Ma'am,
to.
I am sharing a screen.
Okay, do share it. Ritik, can I see your screen now? Are you able to share it?
1 minute, ma'am.
Dear, please make it a little quick so that we can go to next.
Ma'am, his screen is visible to you or not?
Let me just check if some other.
Because I am sharing a screen.
But it is not showing yet, dear. Masood, I'll just show it. Wait a minute.
Ma'am,
Ritik,
ma'am, see now.
oh, yes, now we can see it.
Okay, ma'am. Thank you.
Okay. Let me see. This is the logic for your sorting, na?
Yes, ma'am.
While AI is greater than AI plus 1.
Yes, ma'am. Ma'am, because I take I is equal to j minus 1.
I is equal to j minus 1.
So I compare previous element from the current element.
This won't work there.
No, ma'am.
This won't work. See, why I emphasized on saving the index value, because once you copy it to next element, we are not doing swapping here. That you need to pay attention. We are not doing swapping here. In this case, we are just copying the element to next index value. Even try for the current given example, this won't work.
Okay, ma'am.
Okay, just go for it. This won't work. Okay.
Okay, ma'am. Thank you.
In detail after this, other students will leave. Then I'll share your screen again and I'll tell you precisely the error in your code. Okay. But this won't work. Why the reason is I'll explain you right away with my code. Okay.
Okay, ma'am.
Okay. Okay. Anybody else want to share? Kushik, do you want to present? Masood, your turn is done. You have already presented one code. Okay. Go ahead, Kushik. You know how to share? Okay, we can see your screen, Kushik. Let me just go through your code. J is equal to 0 to j is less than I. If AI is less than AJ, so you are just doing the swapping thing. Okay. Swap kar do, swap kar do, swap kar do. That's not the how the algorithm says. और दोबारा 0 से I तक चल रहा है. Kushik dear, even this is not wrong, not right. Even only if you want. Okay, not able to see your screen. Yeah, now fine. Even you want to try this one first thing. See what you are doing in the inner loop. You may put the condition j is equal to I minus 1 to j is greater than equal to 0 and j minus minus 1. You change the inner loop this way. J is equal to I minus 1 here. Initialize it to I minus 1. And put the stopping condition to be J greater than equal to 0. 0. And this updation condition will be J minus minus. Decrement J every time. Okay. Then also you are comparing AI to AJ. Even still this will fail. I'll tell you why it is failing. Fine. Still this will fail because here in this inner loop, outer loop, you have to save the value at index I. That means as we were saving, temp is equal to AR array at index I. That you need to compare with AJ here. If I move my code on your screen, you can't see that. Na? There is an error, Kushik. I'll explain to both of you, Ritik and Kushik, later on. What is your error? That's good a try, but you really need to understand what's the logic error. Okay? Okay, for now, let me present my screen. Thank you, both of you. But that is very important. Expected errors, these are. Okay? Nothing unexpected it is.
Excuse me, ma'am. Simply we do comparison between current element and previous element, and if previous element is get bigger than the current element, so then we swap it. That's मतलब ये किया मैंने तो coding में.
वही error है. Just give me a second. Look at my code. Then I'll explain what is the error in your code and why that fails. I'll tell you both of them. Fine? Okay. Now look at the code of insertion sort. Look at this code. Look at the logic actually. Just pay attention to the what logic we were following. At every time, at every I would say at every pass, we are selecting an element and comparing the elements less on the index value previous to it to the 0th index. And if they were greater, we will passing them to next array. Fine. If they were not greater, like just look at pass 1. In pass 1, we saved 40 with us. Fine. And we compared value 10 is greater than 40. No. Once it is not greater, we will just stop here. We'll do nothing. Fine. And we'll go to next pass. We'll go to next pass. That is pass second. In pass second, we will select element at index 2. Fine. So simply, we want an outer loop that will help us to tell the number of passes, as well as like in the selection sort, that will help us to choose the element. So we are putting that values to be 1 and less than 4, less than the size of array. So we are starting that index outer loop variable with value 1, because at pass 1 we want to select element at index 1. That's why we are not following that we are not following this logic. S minus 1. We are not following this logic. We will be sticking to this logic. We have reason for this because we want this outer loop, to do two things for us, similar to selection sort, that it will tell you number of passes. It will keep check of number of passes. Fine. It will tell you the index value, or it will tell you actually the key value we are selecting in every pass. Fine. Similar thing the selection sort outer loop was doing. So we coded it same way. Fine. Now let's go to inner loop. Now let's go to inner loop. Fine. What we are doing, pay attention here. As I was repeating in the example, that whatever value you have at that index in that pass, say pass 1, in pass 1, we saved element at index 1. That is what we did. We saved element 40, if you recall the previous example. So we saved element at index 1, which was in particular example was value 40. Fine. And we wanted to compare to index 0 element. We want this value to compare to this element. Fine. And we have only two ways to go. Either it will be less than or greater than. Fine. If it would have been less than this one, we just stop there. We don't want to do anything else. Fine. But if it would have been greater than, then what we wanted is, we want this AI to be jumped to next index value. That means we want A1 to be equal to A0. Fine. That is the logic we are following. For this particular first pass, when 40 and A0 is 10, it is less than 40. Less than 40. So we want to do nothing. We just want to stop here. So that is how we have placed this condition. See, first your indexing will go from I minus 1 to what maximum index value it can go? To greater than equal to 0. Fine. I minus 1 to greater than equal to 0. As well as we want this inner loop only to go if the value of Aj is greater than value at, okay, sorry, this is an error. Don't compare it with AI, compare it with temp. I am sorry for the error. Compare it with temp, not AI. Please make this correction in the code, okay? Instead of AI, here you will write temp, this variable name. Right? We just want this loop to go if this value, that is 40, is greater than 10, 40. Sorry, 10 is greater than 40. Only in that case, you go in this loop. Like only in that case, you keep on copying element to next index value. Right? Otherwise, if that is not the case, just stop it. So just look this code, how this code works for I equal to 0 for the given example. When I is 0, you save in temp value 40. Fine. J will be 0. Fine. I minus 1 initialize to 0. J is justifying the first condition. It is greater than equal to 0. Fine. And then we say we want to compare element at Aj, that is A0, which is 10 to be greater than temp, which is 40. But it is not so. So it will not execute this loop body even once for the first pass. When the value of I is 1, J is 0, for that case, it won't execute the body of this loop even once because this condition was not true. We have put a logical AND. Fine. So this condition is not true. So it won't execute even once. And this line would be executed. What it is saying, at A1, if you put it in value, J is 0. So 0 plus 1 is A1 equal to temp. Temp is 40. And already at A1, we have value 40. Is that okay? That is what we were doing. Fine. Now look the same code. Look at the same code for second pass. Look at the same code for second pass. For second pass, I is updated to value 2. After this execution, I is incremented and now I is 2. Fine. Now, with temp is equal to I at value 2. Fine. And what is that value? 2. See, at index value 2, value is 2. This case, second pass we are taking. Fine. So, sorry. So, I is equal to 2 and temp is equal to A2, which is in this particular example is value 2. Am I good with this? Fine. Now J will be initialized to I minus 1. So J initially here is 1. 2 minus 1 is 1. Fine. And you just, I'm giving you that values. Now we have values 10, 40, and 2 at index value 2. This we are accessing in temp. Fine. Now for J equal to 1, J is initialized to 1. We check this condition. J is greater than equal to 0. Yes, 1 is greater than equal to 0. Now we compare this value. Again, as I said, this was error. You will treat it as temp, not AI, temp. Aj is greater than value at temp. Aj, that is J is 1. That means this value. Aj is 40. 40 is greater than temp, that is 2. Yes, This condition is true. So this is logical and this is true, this is true. So the condition is true. The control will go inside the body of the loop and this will be executed. Fine. This is executed, so it is just doing is j plus 1 copy value of aj. So now here it is 40. Fine. Now here it is 40. That is what it is doing. Now closing parenthesis of inner loop. Again j is decremented. So now j is instead of 1, j is decremented to 0. Again check the condition. J is greater than or equal to 0. First condition is true. Logical AND. Second condition says the value at 0, A0, that is 10, is greater than temp. Temp is 2. 10 is greater than 2. Yes, it is greater than 2. 10 is greater than 2. Fine. So this condition again true. So again the body of loop will be executed. And now it says at aj plus 1, like that means at j 0 plus, at a 0 plus 1, that means a1 copy value of a0. This copy it here. So copy 10 here. That is what we are doing. Fine. Now again j is decremented. In this case, j is set to -1. J is set to -1. Again we check either j is greater than or equal to 0. No, this condition is false. J is -1. -1 is not greater than or equal to 0. So we need not to check second condition, as I told you in logical ORs, logical ANDs. In logical AND, if first condition is no, so we need not to check for the second condition. Right? So it is no, the condition is false, so the body will go, the control will go out of this for loop, right? And will execute this line of code, right? And what this line of code is saying, a j plus 1, j is -1, so -1 plus 1 would be 0. At a0, put the value of 10, that is 2. So at a0 here, put the value 2. There the second pass ends. Fine. I is equal to 2 is second pass. Second pass ends here. Is that simple? Is that simple? So after second pass, you will have 2, 10, and 40. And they are in their respective sorted orders. Am I clear with this part? This is important to understand. Fine. So I'll just execute you once again for the third pass, which is very important. Let me just see the values at third pass. Okay, this is the third pass. After third pass, so input to third pass is this values: 2, 10, 40, and 3. Let's do this. Two, 10, 40, and 3. This array we have considered array for this path. Fine. We have element after this too, but that is not hard. So now after the previous execution, I is incremented, and now I is set to be 3. Am I good with this? In previous execution, I was 2. Now I is 3 for the third pass. So this is the element we are dealing with. Fine. So temp is equal to 3. Okay. Okay. Now j is initialized to 2. Fine. That is what it is doing. I minus 1, I is 3. 3 minus 1, 2. So j is 2. Now check for this condition. 2 is greater than or equal to 0. Yes. And aj, that is value of a array at index 2, again as it was the correction, it is 10. Not ai, it is 10. Right? aj, that is at index 2, this value. 40 is greater than value at temp, that is 3. 40 is greater than 3. Yes. Fine. The case. We were saying the element we are comparing with the same element. If it is greater than this one, that is a problematic situation. We need to swap it to next place. So aj at index 2, that is 40. 40 is greater than 3. Yes. So it will go inside the loop, execute this line of code. What this line of code will do, aj plus 1, that is at this index value, copy value 40. Fine. Copy this value to the next index. That is what this line of code is doing. Fine. Then decrement j. The body of for loop is, inner for loop is over. So decrement j, this will be executed. Now j is 1. Right? Once j is 1, we'll again check the condition. 1 is greater than equal to 0. Yes, again. We'll check this condition. A at value of a at index value 1, that is 10. 10 is greater than 10, that is 3. Yes, again true. Fine. Again, like the comparing element is greater than the considered saved element. Yes. So we again copy to this. So we again copy 10 to 40. So 10 at next place. So this time 10 is here. Fine. So we just copied this to here. Earlier we copied this to here. Fine. Fine. Again we decrement j. This execution, j is 0 now. Again we check 0 is greater than 0. Yes. Greater than equal to. So equal to, yes. Now a at 0, that is 2. 2 is greater than 3. Is 2 is greater than 3? No. Condition is false. So yes and no, logical will be no. That is a or no bolo or false bolo, false condition it is there. Once it is false condition, then it will come out of this inner for loop. Fine. And it will set the value. It will set the value of j plus 1. That is j is 0 plus 1 is a at index value 1 will be equal to 3. So a at index value 1, here we copied 3. Fine. So after this third loop, it will be 2, 3, 10, and 40. Simpler? Simpler? Fine? 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 Okay. Let's execute just once more for the last loop, so you will understand exactly how the code is working. For the fourth pass, I will be 4, fine, and the initial values are 2, 3, 4, 10, and sorry, this is after third pass. अभी हमने third pass किया ना? Yes, अभी हमने third pass किया. अब we are doing considering the fourth pass. This one. So the input values will be 2, 3, 4, 40, and 4. Do we need to do this, or you are okay with this? Two, 3, 4, 10, है ना? 4, 10, 40. 2, 3, 10, 40, and 4. These are the element values. For fourth pass. Do I need to do this, execute this for this loop as well? How this outer loop is working, how this inner loop is working. Just see. Look at the logic. I feel like you don't get confused. Just look at the logic I'm telling you. You're okay now? See, just look at the logic I'm trying to explain you. What we are doing in every pass is, in every pass, we are selecting an element at that particular index value. In first pass, we are selecting the element at index value 1. That is the second element. And we want to compare it only with the elements to the left of this element. Right? So we selected element, say, randomly, let's take a pass. We'll take pass 3. Right? So in pass 3, we will select element at index 3. And we will save that value somewhere. Right? And then we'll compare element at index 2 with this saved value. If it is smaller than this, then we will just stop there. We do nothing. Right? But that is the simplest case. Right? But second case, if this element is greater than this element, the saved element, in that case, we will copy this element at index 2 to next index value. Fine. So now the element at index 2 is copied to element at index 3. Then we'll compare element at index 1. We'll again see it is greater or smaller. If it is greater, again to the selected one. we'll again copy it to next index value. We'll copy element at index 1 to element at index 2. Fine. Then again we'll check for the next element. We'll pick the element at index 0. Fine. And now suppose we say that the selected element at this point of time at index 0 is smaller than this one, selected one. We have this in path 3. It is 2 and it is 3. It is smaller than this. Then you need not to further scan the array to compare to the selected element. You will stop there. Fine. And what we'll do, at which index value you stop, to next index value you will copy the saved element. That is as we were doing when it was 2 at index 0 and the saved element is 3. So we stopped at index 0 and at index 1 we copied the value 3 and we further need not to compare it. The simple logic it is saying is whatever pass we are dealing it, we are selecting that element and we are looking all the elements previous to that element are smaller to this. If any, like just the previous element is smaller to this, so the remaining also are smaller to it. So you will stop there. Fine. But if say this element is greater than this, that means it should be here and it should be somewhere previous to this place. That we are trying to find the right place of it. As in the game of cards we do. We have cards, we pick element one by one and we see, okay, if it is greater than this one, we'll do nothing. We'll keep it here. If this element is is smaller than this one but greater than this one, so we move it to this place and we move it to here. Fine. And second case, if this element is smaller to this one, even smaller to this one, so move both these cards to this place and copy this element to here. That is what we are doing. Fine. Is that okay to everyone? You all are good with this? Fine. So these are the 3 basic sorting techniques that we need to understand.
And can you once again show the code?
Okay, let me present my screen. Okay, just a second. I think I can